been a while since I've made any content on YouTube, but I'm back. I'm going to try to get back into the swing of things. And today we're coming in hot with a lot of very dense content. I've learned a lot over the last couple years, and I have been specifically working on this particular project for the last week. And it's basically how to deploy a REST API that uses a database on AWS. Now, that sounds like a really vague and ambiguous phrase because there's literally a million ways to deploy a REST API with a database on AWS. However, here's how we're going to do it today. We are going to create a virtual private cloud so that all the services we create, specifically RDS and ECS, will exist in their own little private network. We're going to use RDS, which is AWS's fully managed relational database. This actually comes with a lot more options, but we're going to be focusing on Postgres today. And then we are deploying our app in a container that's made with Docker in ECS, which is Elastic Container Service. And here we're going to cover setting up a cluster, setting up task definitions, setting up the services that'll run those task definitions. These are actually out of order. Task definitions should probably come first. And a little bit about load balancers, not very much at all. That's pretty automatic. Services and this is all going to be done in the console on AWS, and console to them means in their web application. Yes, we could be really cool and hack all this out in the terminal, but I want to be beginner friendly as much as possible because there is a lot here. So we're not going to do a whole lot of terminal hacking just yet. The next is ECR, which is the Elastic Container Registry. It's basically like Docker Hub. So this is where we're going to host or put our image that we create with our Docker. And then we're going to tie it all together with a code pipeline at the end. This code pipeline will pull source from GitHub. It will build it in AWS's code build using a file called buildspec.yaml that exists in our source in GitHub. And then it's kind of code deploy, but it's kind of not. It's basically code pipeline's version of code deploy that will basically launch this whole thing into ECS. So without any further distractions, let's get started. We're going to jump into, let's create a VPC first, get that going. This should be pretty simple and quick. VPCs, create a VPC, and we're going to call this one Nest REST, because by the way, the application that we are going to be deploying today is just a simple NestJS REST API that connects to a Postgres database. Not too fancy. It does have some endpoints that we can play around with if we have time, but really not the point of the video as so much as how to get this application that's already built deployed onto AWS using ECS and Fargate. By the way, I didn't write this down. Probably should have. We are going to be using the Fargate runtime, I guess is what I'm going to call it right now, that instead of setting up like an EC2 instance and running our containers there, we're going to be leveraging Fargate, which basically allows us to run our containers without having to think about the hardware that they're running on. We get to specify how many CPUs and how many gigs of RAM we want the container to have access to. Obviously, the more you go in CPU and memory, the more Amazon is going to charge you for that. But anyway, we just specify that and Fargate takes care of the rest. We don't have to spin up EC2s and manage their system and updates and upgrades and all of that. We just throw our container at it and largely call it a day. But as any security expert will tell you, that that's not entirely true. But we're not here to talk about that today. So let's get back here. We're going to do VPC and more. I want to also generate subnets. And in this case, tenancy default is fine. And we're only going to do one availability zone for now. I don't think we need any public subnets. We may have to come back and fix this, but let's just start with one private subnet because I believe our load balancer can route to the private subnet. We'll find out if I'm wrong on that one. This is actually the one untested part of my my little show here. So don't need any NAT gateways, don't need any VPC. Well, it's set up for S3, none. We did need, where are we at? Oh, okay, so I'm sorry. We do need a public subnet because we need an internet gateway. Interesting. Okay. All right, fine. I guess we need a public subnet and private subnet. Again, this may be the part of the video that I'm not as familiar with. So let's see what happens. Create VPC. This will spin up, create subnet, internet gateway, create route table, view VPC. Said view VPC. I don't know why it took me here to create. That's weird. Here it is, Nest VPC. Cool, we've got this spun up. Now, let's get our database started because that takes a little bit of time. And while that's spinning up, we can work on these other items, getting ECS cluster set up. DB, create a database. Let's do it. We're going to use mostly defaults here. Keep it fast, keep it simple. And the nice thing is whenever this finally loads, Amazon already defaults to a Postgres SQL. We could change the version here if we want. We'll just leave that default. And we are going to change this to free tier so we don't get charged a whole lot of money because this is just a demo video. You get to decide in real life whether or not you want to do these other methods. Database identifier, we'll call it Nest REST Postgres. Master name. I got a master name that I'm going to use that's not Postgres. So, sort of already lying here, aren't I? I said we're going to use mostly defaults, but here I am. So, NestRest2 admin, and then my super secret password. And we can even step down a notch. We don't even need a full T3 micro. We can do a T4G micro, 2 CPUs and 1 gig of RAM. I don't know really what the difference is, but this one supposedly is like a few pennies cheaper. And even though I'm not going to leave these running, every penny counts. So storage should be fine. Have to have a minimum anyway. We don't need storage auto scaling. That just might add to the cost. We don't need to connect to an EC2, and we're not going to use the default VPC. We're going to use the private network that we created. Now, we could, and this is what I did last time, create new VPC, and then I just used the VPC that RDS created. However, as you saw, I decided that for this video, I would create one from scratch just to show that. That may have been my undoing. Maybe I should have just stuck with my original work through and create a new one using RDS. But let's go on an adventure here. Nest REST VPC, the one that we created moments ago. Create DB subnet group. Interesting. Okay, I guess we're creating a DB subnet group. Obviously, when you create your own new VPC, this option is going to be the same. But heck yeah, fine. It'll create its own subnet group. We don't need public access. You could if you want to, but for this project, we don't need it because we're going to deploy it all within this virtual private network and then get access to the app, the REST API, through the load balancer. So we'll leave that no. Security, VPC, choose existing. I'm going to leave it default. That's fine. No preference on availability. RDS proxy, no. Password authentication, yes. We do want to leave that the same. We could turn this off. I don't think I need it. I don't know if it costs any money. It says 7 days free tier, but as I've been working through these tutorials, I've been getting charged pennies. So I'm just going to keep shutting stuff off and hope that I get charged less. Yeah, here it says estimated monthly cost, which it says it's in the free tier. I don't believe it because I've already gotten charged a few pennies for working on it, but whatever. Create database. We're going to let this go. Oh, your request to create DB instance nearest NestJS Postgres didn't work. The DB subnet does not meet availability zones. Okay, we're going back to the original way that I did this. Oh, you know what? I made that VPC in a different zone, didn't I? So this is another little thing you'll learn in AWS is making sure that you are creating things in the regions that you know are wanting to have them created in. This says North Virginia. Normally I do this in Ohio. I don't know where. Okay, yeah. We're definitely taking a detour. All right, I showed you how to create a VPC on your own, but we're not going to use it. Moving on. All right, come back to RDS. Interesting. Create database. Now I got to run through all of this again. If I change the zone now, is it going to stop me? Yeah. Don't like it. Okay, standard create. Postgres SQL 13, free tier. Nest, rest, Postgres. Let's see if we screw this up again. Okay. Oh no, I was in there. Why? Default subnet group. Create a VPC. Create a new DB subnet. All right, this is how we're doing this. We're creating a new VPC here and letting it create its own new DB subnet because this will do things automatically for us that I know will work. You can go back in and change things in that VPC later if you would like to. But the main point is we're not using the default because imagine you're working in an organization and you have lots and lots of VPCs. Well, chances are they're VPCs for a reason. They are there to keep the services that run in those networks segregated and private. So for you to just choose a default or choose an existing one is actually probably a no-no, you know, as far as your company policies are concerned. So creating a new one is not a bad idea at all, especially when you're setting up a whole fresh new service. I'd recommend you not using an existing one unless you really know that that's what you want to do. So create a new VPC, create a new DB subnet, no public access. Using the default is fine. Availability zone, no preference. Password authentication. We don't need performance insights. And let's see if it works this time. Create database. All right. Creating database. NestJS, Postgres. Your database might take a few minutes to launch. All right. What's next on our list? Let's head over to ECS Elastic Container Service and get that rolling. Come on. Sign into console. We'll have 12 tabs open by the end of this. ECS, Elastic Container Service. Okay. I like the new experience. You can use the old if you want. Here we go. We're going to hit clusters. create a new cluster. We'll call this NestRest ECS cluster. And here we're going to select, we're lucky in this case because I have the default VPC, and the only other one that it could be is the RDS one that's being created back here in the database creation. So I can create that. Choose subnets. Just choose them all. I don't know exactly. Yeah, choose them all. That's what I've been doing. It works. We're going to leave AWS Fargate. That's the default. You would be moving up into other options if you wanted to do EC2, but we're not. We're going to do Fargate. Monitoring, we're good. Tags, fine. Create. And we're also going to set up ECR while that spins up. Nope, ECR. Here we go. ECR, Elastic Container Registry. Create a repository. We can make this private. That's totally fine. We'll call this NestRest ECR. All right, and that should be good. Leave everything else default. Create repository. Cool, cool. Come back here. There was an error. Resource handler error occurred. Service unavailable. Please try again. This might be because the VPC, the RDS, isn't finished setting up, and so maybe there's some VPC stuff that's not finished. So we can hold off on that for a minute. Let's actually move on to the task definition. So here's how this kind of works. We have our cluster. Our cluster runs a service, and our service runs task definitions, and the service will also spin up the load balancer that will give us access to our tasks. They call them tasks. They're basically containers. That's how I'm kind of looking at this. So if we go back and do a task definition, we are going to point it to, we'll first create a new task definition. We can call this NestRest task def. All right, and we'll call this NestRest. This is the name of your container. So here we are setting up a container, and we're going to go back here and grab this URI and just paste that bad boy right in there. And at the very end, we'll do :latest. Obviously, we don't have anything in there yet, but when we do :latest, we'll just pull in the latest, whatever we get in there. All right. Container port 80 is fine. This is all fine. We do need to add an environment variable, and that is database URL. Oops, stupid thing. Okay, database URL. And here's what the database URL looks like. This is basically all set up. The only thing that I need to change is this. This local host is for running this application locally. If we go back to RDS and click on it, we do get an endpoint that we can grab, even though it's not finished yet. This is the endpoint that your database will be at. Hit copy. I'm just going to actually do a paste right over localhost, and I'm going to grab this whole string minus the quotes. I don't need those quotes. Copy, and come back to ECS where we're creating our task definition. Value type value is fine, and paste. That's all we need there. Should be good. Okay. I think that's it for this screen. Next is we're going to set up Fargate or EC2. We're going to use Fargate. We are using Linux, x86-64 architecture, and we're just going to use the smallest possible. I swear there's a smaller size than that. Quarter CPU, half a gig of memory. Smallest amount available, I believe. Yeah. Quarter CPU, half a gig of memory. This is for the task size, and then there's container size. So a task can hold more than one container, and each container, you can add basically or configure how much you want each container to use of your task. So right here, I'm using 1.25. So this is pointless, right? I'm not going to use one. There's not that much there. But if you had a bunch of containers and you wanted to all run them in this one task. So for example, let's say you had an Nginx proxy next to your Nest REST API or whatever. A million ways and million reasons why you might have multiple containers. You could do that here, or at least set up the spread here. You'd have to set up the extra container in the previous step. Let me come back. So if you look, you can add more containers. But for this demo, we've just got the one. And we only need, we don't need additional container size. So that's optional. Task roles, leave that one alone. Task execution, leave it to create new role. Don't have one to select anyway. Network mode, you can't change. This is because of Fargate, and that's fine. Storage, it's optional. Supposedly it has some ephemeral storage anyway. Obviously it has to, but we don't need any extra. Monitoring logging, I do like to use this. It's very helpful when you're trying to debug to see what the heck logs your container is spitting out. It's kind of like using Docker logs. Command in your terminal. Here it's just a web page that you can go to and read it. And next. Okay, I'm going to close some of these because they're kind of disturbing. And this is just a confirmation page. Basically, read over it and decide if you like it or not. I like it. I hit create. Task definition is being created. So, check on our database. Successfully created the database. Okay, so that's created. Our task is created. Let's try setting up our cluster again. We'll call this Nest REST ECS cluster. And remember, we want to choose the VPC that our database is using. And if we look here, it's VPC 02831 yada yada. And that's what we got selected here, 02831 yada yada. Subnets, choose them all. We'll let them go. And Nest ECS clusters, fine. Fargate's fine. Monitoring's fine. All of this default is fine. Create. So we do have to wait for this. While we're waiting for that, I'll just show you what the application looks like. This is what I've just got this running locally on my machine in Docker. So I have the Postgres Docker container running and the application Docker running. And obviously here on local, I need to spin up Postgres, but because we're using Amazon RDS, I only need to run this container. And you really don't want to get into the mess, me personally, I'd say, of trying to run a database in a container in something like ECS. You're just going to, I'm not discouraging you from trying. I think that education is a very good reason to try anything. However, I think it will be you'll come to the same conclusion, basically, that databases are really not, or any data storage or persistency of any kind really isn't the right place to put. ECS is really not the right place to put those things. So, or any container orchestration necessarily. I'm sure there's people out there who do it, and there's probably people watching this who might even disagree. I just think that using a database service gets you ahead of the game. There's a lot less stuff you have to do and think about, to make it work. So yeah, this is the application. It's basically just got some auth endpoints, some user endpoints, roles and permissions, yada, yada. Let's check on it. Okay, cluster is created. And now we've got our cluster. Let's just look here what we've got. We've got our VPC, got RDS, and Fargate is a part of ECS. So it's just there as a, note. We've got our cluster set up, and we've got our task definition. Now we need to do service. Oh yeah, we've also got ECR. So we're getting there. So let's set up the service. And that's as easy as if you're coming into this fresh, let's close these notices, then hit clusters, and you should find your cluster in here. Click that, and it's right down here. Should be the first thing, services. There are none. Let's create one. And for this, we don't want to mess with capacity provider strategy right now. This is just a simple example. You can learn about this later. So we just want a launch type. It's real simple. Launch type is Fargate. Platform latest. So the latest platform version of Fargate. The application is a service. It is a long-running task. We want it to stay running. Task would be like a standalone thing that runs and terminates, for example, a batch job. And we do want to, here is where we point it to our task definition, right? Task definition, and there's only one revision right now. And we're going to name this service NestRest ECS Service. I feel like there's a lot of rhyming. Like I couldn't have picked a worse name for trying to say this on a video. Okay, desired tasks is 1. That's fine. Deployment options, this is just like kind of some health metrics, checking, make sure everything's running good, failure detection. All this can be left basically alone. This VPC should already be pointed to the correct one, and all those subnets should already be there. Here it's going to use an existing security group, SG, that's fine. You can turn the public IP on. That might be helpful for debugging if you have trouble. Just keep in mind that public IP actually will not route from the internet into this container by default. You have to go into this rule and turn on basically an inbound rule, a network inbound rule. But we shouldn't have to worry about any of that because we are going to turn on application load balancer. And this just makes it all that much easier for us to access our REST API. We'll call this NestRest LB for load balancer. And we're going to let it load balance to our NestRest container on port 80. It's going to map port 80 to that container's port 80. And it's going to create a listener on port 80, yada, yada, target group. We can name this NestRest Target. Health check. So the root path of this app actually returns a 404. So I don't think that that's a good health check. Yeah, see, it's just 404. So in this case, I'm going to actually point it to that page, that API page, because then it'll at least return a 200. If in fact it even uses these, I'm not 100% sure that it does. We don't want any scaling right now. This is all stuff that you can look at when you start getting into production. Manage tags is fine. It's supposed to help you identify stuff when you're looking at your 100-page bill. All right, that's it. Create service, which is also going to create our load balancer for us. And it's going to pull in, or try to pull in, our task definition, which is pointed to our container registry, which has nothing. So right now we're wired up, but we got nothing at the for it to run, no image for it to pull to run. So we could do this in the terminal and just throw an image in here really quick for testing, but we're going to go another layer deeper and set this up in a pipeline that will source from GitHub, build it using a build spec YAML, which I will show you that, and deploy it to the ECS cluster. So let's get started with that. Go to code, pipeline. And I'm going to do one thing really quick that I know I forgot to do earlier, and I'm just going to delete this so you guys can see the step that I have to take to connect to my GitHub. It's really simple. So pipelines right here, getting started, pipelines, create a pipeline. We'll call this NestRest pipeline. line. And new service role is fine. This is going to create basically a service role for the code pipeline so that it has permissions to do things. Allow it to create a service role. Yeah, that's fine. Sure. All these defaults look good. Source provider. We are choosing GitHub version 2. And right now I have no connection, so let's connect to GitHub. And because I'm already logged into GitHub, I should be able to, we'll just call this Sax GitHub. Just hit connect to GitHub and it should just open a new page. Interesting. All right. I got to back up. Applications, integrations, AWS connector, configure. Delete, uninstall. 48 repositories, yes. Okay, starting over. So we're going to create a pipeline and we will call this nest rest pipeline. Allow, yep. Okay, so it's going to create a new service role that gives it permissions to do some things, and it's going to be allowed to, create the service role. All these defaults are fine. Hit next. And now we're going to choose our source provider. This is going to be GitHub. And right now I don't have anything, so let's connect to GitHub. We'll call this Zax GitHub and connect. And this should just take us to, I'm already logged into GitHub. I have a session in this browser. No, okay, so I hit connect, install new app. Here we go, Zach Langton. All repositories is fine for now because I'm going to probably take this down when I'm done. Install. And there we go. That was quick and easy and painless. Connect. Your GitHub connection is ready to use. Repository name. So we are looking for Nest Rest 2 API. Branch name, there's only one in the main. Start the pipeline on source code change. So this will, anytime we push a change to the branch main, okay. Start the pipeline on source code change. So this will, whenever we push any code changes to this project, to the GitHub main branch, it will automatically trigger this code pipeline, which is awesome. So output artifact, code pipeline default is fine. We'll hit next. Build provider. AWS code build is what we want here. Region Ohio. And we're going to create a new project. So this is the build. This is the AWS code build project that we're about to step into when we hit this button here. We're going to hit create project. And I like to expand this a little bit just to make it a little easier. We'll call this nest rest code build. Nope, don't. Most of these options are fine. So managed image is what we want. I like Amazon Linux 2 or Ubuntu is the new recommended. So if we choose programming language runtimes are now included in the standard image, which is recommended for new code build projects created in the console. So we're choosing Ubuntu, standard runtime, and I always pick the latest image just because I like living on the bleeding edge. I always use the latest image for this runtime. That's fine. Environment type, of course, is Linux. Looks like you could do a GPU. I'm sure that costs more. Privileged. This is important. We do need to enable a privileged flag because we're actually going to build using Docker, and it needs to be a privileged container in order for Docker even to be available. So that's important to be checked. We're going to let this create a new service role, and we will have to add a permission to this new service role. And I'm going to show you how to do that when we're done in order for this code build to be able to push to the ECR registry. So, okay, we could do some additional stuff. Not going to at this time. Yeah, it's a little weird that you can set environment variables here. Also, it probably would work the same, but I'm not going to put the environment variables that I want in here. I'm going to put them. I'm trying to think what environment variables I need. Oh yeah, I know what environment variables I need. Okay. But I'm not going to put them in here. I'm going to put them back here in the code pipeline. It also allows you to set code build environment variables. So not really sure why you can do this in two places. Maybe someone else knows. Post down in the comments. Let me know. So that's all fine. Build spec file, insert build commands. Nope, we're going to use a build spec file. So let's look at that now. I'll pull this up over here. It is this guy. So this build spec is a file that's basically specific for AWS code build. And it's a lot like GitHub Actions, or maybe even, similar format. I mean, it's a YAML file, so it should be relatively familiar to a lot of you. I like it to, kind of think of it as a GitHub Actions. Really, that's where I think it fits my mental model best, because you have these commands, right, that you're trying to run, and you have these different stages, I guess. Pre-build, build, post-build, and these all just kind of show up when the build is happening to let you know what stage your build is in and things of that nature, just to give you some nice visual when you're looking at the build actually happening in real time. So that makes things kind of nice. But what we need to worry about here is the environment variables that we're going to pass into code build are variables that get fed into the build spec YAML. And there are two very important variables that we need to pay attention to. One is repo domain and repository URI. And we're getting both of these from ECR. So what this is doing here, we're just logging into ECR, and that's why we got to put in the domain for it. And we're getting some other variables set with commit hash and image tag. We're going to call it commit hash or latest. I'm just doing some echoing for the logs. And here we actually build the Docker build, and we tag it with the repository URI :latest. And then we also tag it again with latest, and then the URI, and then the image tag, which we get up here. And then it goes through echo build completed. This is kind of like an artifact. Like, to be honest, I'm not even really sure. This actually comes from the tutorial in Amazon. So I went to this page here, and it's basically, tutorial Amazon ECS standard deployment with code pipeline. It doesn't go through everything that I'm showing you here, but it goes through the code pipeline part to get stuff into ECS and also ECR, and it comes with this beautiful example. I've changed a few things. Mainly, here they're hard-coded this URI, and I wanted that to be a variable. So I changed it to repo URL or URI or whatever I chose. So yeah, that's where this all comes from. So that's why this is here, and I've left it, even though I'm not 100% sure what it's useful for and whether or not it's necessary. So again, anyone in the comments want to let me know why this is useful and or maybe why I should take it out. That'd be great. Thank you. So that is the build spec YAML. These sections are the ones that really do the bulk of the work, and then this does something else that I don't really know, but I leave it in anyway. Okay. Moving on. Coming back to the code pipeline, actually the code build, because we weren't done with that. So we're going to use the build spec file. That's the file I just showed you. If it wasn't named buildspec.yaml, you'd need to set that here. We're not doing any of this. CloudWatch logs is perfect. I don't think we need to set group name or stream name. Maybe we will. We'll just call it nest rest code build logs. And then, yeah, I don't know. Stream. Names were not something that I had come up with prior to engaging in this video. I just came up with those just now. Continue to code pipeline. Come on, continue to code pipeline. Yeah, there we go. So, as you see, we created a project in code build and it automatically filled that out for us here. Now, we're going to add these environment variables. I'm going to bring this back over for a minute. I'm going to pull in repo domain and copy, paste, add another one, and repository URI. Okay. And we get those again from our ECR repository. So the URI is real simple. It's this whole thing. And we're just going to paste that whole thing into the repository URI. We are going to do the same thing for domain, but we need to delete the very end, including the / so that all we have is just the domain part. And how you know that that's what you need, or at least one way you can kind of tell it's what you need, if you come over here, they have also this really nice helper. You can click the repository and then hit view push commands. And this is telling you, if you're running this in your local client, what you would type in pretty much to a T. You can just copy and paste this right into your terminal and it will log into the ECR in your local machine and then build and then tag and then push. And if you notice, this command here is pretty much exactly the same command that's in our build spec. Slightly different, but very much the same. So that's where a lot of this comes from. And some consistency for you in AWS. Okay, so we've got those pasted in. We've got our environment variables, single build, and we shall hit next. Now here comes the deploy stage, which is the end. We're getting super close, guys. So deploy provider, we want Amazon ECS. We're going to choose the cluster that we created earlier. We're going to choose, ooh, what happened here? There was an error deploying NestRest ECS. Was triggered request token, blah, blah, blah. Okay, so this failed. Let's try again. Create a service. Launch type. Fargate. Service. Task. Family. Nest test def revision. Latest one. Service name. Nest. rest dash service. Okay, replica, deployment options, service connect, load balancing, application load balancer, VPC is good. Use the existing security group. Create nest rest dash LB. Map to port 8080, listening on port 80, target group name, nest rest dash target, health check slash API. No auto scaling, tagging is good. Create, please work this time. Because you are the last little linchpin. We need you, service. We need you so that we can run this beautiful API service and get it pulled in from GitHub. In fact, we'll just go to GitHub real quick so we can see. This is it. Pretty simple. It's a NestJS project. This is the repository that we're pulling from in our code pipeline. And here's hoping that this service is going to work. This doesn't look promising. There's always problems. NestJS service deployment is in progress. Tasks. Why are you taking this long? Normally it doesn't take this long. I click. View in CloudFormation. Let's see. Let's see what kind of activity is going on over here. Rollback complete. Create in progress. Stacks. Target group, create complete. Resource creation. Create complete. Are these recent or no? No. Okay. So this is the new one. This must be the one that failed us about 20 minutes ago, less than. Please don't fail me. Oh yes, okay, we're getting close. Nest rest service. Q. Getting closer, getting closer. Configuration and tasks. This is our task definition. It says it's running. We're getting close. We're getting close. Even though, here's the thing that's definitely going to happen is because there is no image there, this will fail. So here's what we can do. While this works, because it may break again because we don't have an image in here, we can actually skip the deploy stage for now and add this later. So let's do that. Your pipeline will not include deployment stage. You sure you want to skip this stage? Skip. Okay, so what we've got here is a pipeline that will pull from GitHub and build it. Pipeline settings, pull from GitHub and build it. No deploy yet. All right. So we're going to create this pipeline and we're going to let it run those first two stages. It's going to pull in the source. It's going to build it. And it's going to push it to ECR. So here we are, source in progress just now. Pulled it in, probably pulled it in real fast. And here we should see in very few short seconds. Oh, GitHub succeeded. AWS code build just now, details. And then we'll start seeing some wonderful, beautiful logs. While we're waiting for some of those logs to come through, let's look back here. Okay, so yeah, we do see this happening. This is happening because there is no image currently in our ECR repository. So it's a little bit of a chicken or the egg situation. This is where you go, Zach, why are we setting up a code pipeline when we don't even know if our ECS, deployment works? That's an excellent question. You're right. We normally wouldn't do this. You would just do the ECS part, the ECR part, the RDS part, and then go into your terminal and type in some wonderful commands to push and build this to ECR, and then make sure everything works there, and then go and set up a code pipeline. Yeah. That's one way to do it if you really want to. I think it's more fun to build a code pipeline. So let's check it out. Yeah, it's still chugging. It may fail again. It may not. Let's check this one. We've got some logs. Oh no. Oh, yeah, I did this again. So I forgot to show you guys. The tutorial tells me to add Amazon ECR permissions to code build role. It's this guy right here. Amazon EC2 Container Registry, our user. Copy. So we go to our security credentials. We go to roles. And what we're looking for here is the code build role that was created for us, which is right here. Code build, nest rest, code build, service role. And add permissions, attach policies. I'm going to paste this in and search because there's a bajillion of them, and checkbox, attach. Policy was attached. Perfect. So now if we come back here, we're going to hit, where would it be? Code build, pipeline, pipelines, failed, right? And retry. Okay. And we wait again. We wait some more. We wait for the code to build. Come on, code build. Come on, code build. In progress, details. View log. Clusters. I'm going to close this because I don't need it. I just don't need it. Nest ECS cluster. So it's basically working. I wonder if we can try. What if we can throw this in while the code build is running? Let's try it. Pipelines. No, actually, I'm pretty sure we can't because oh well, let's try it. Add a stage. Stage name. Wait, nest pipeline, is this right? Source, build, add stage. Deploy. Add stage. Add action group. Action name. Action provider. Wow, this is a lot more. Why do I feel like this wasn't how it worked before? But okay, here we go. Choose action name. Deploy. Pretty sure that was the name that I just gave it. AWS Amazon ECS East Ohio. Build artifact. Why do I feel like I'm screwing up right now? Nest ECS, service name, nest rest. These can be left blank and done. Okay. Save. Save. It says failed. Why failed? Why you fail? Build projects, nest code. Did it fail because I saved a code pipeline in the middle of the build? Error while executing command docker push repository exit status 1 exiting expanding. Oh, why are you failing? Command did not exit successfully. Running command. Is the Docker daemon running? Okay, I guess maybe Ubuntu doesn't have this. Maybe it has to be Amazon Linux. So let's change that. Interesting. So in the code build, build project, nestcode build. We hit edit environment and override image. Interesting. So Amazon Linux 2, and by the way, it does say to use Amazon Linux 2 in this guide. I just thought maybe this guide was slightly outdated, but maybe it's not. Maybe it's exactly what it needs to be. So Amazon Linux 2, standard image, always choose the lightest, and make sure privilege is checked because it won't work. See, this was available when we ran Ubuntu for the same exact same text. So, okay, update environment. Coming back to the pipeline. Well, let's try. Let's retry again. Oh, build. Stop. Oh, definition has changed. Okay, so I'm just going to trigger minor readme change. We'll just add an enter to trigger the code pipeline all over again. Commit code pipeline. Source in progress. Succeeded. Build details. Let's go, chat. Let's go. Progress. Elastic Container Service. Amazon. Logging into ECR. Complete. Here we go. So Docker appears to be running now. Interesting. Take a note, audience. Apparently Ubuntu doesn't work. That doesn't seem right. It seems I swear that it even said in the text that they were recommending Ubuntu. Did I not read? Do I not know how to read? Whatever. It's building now. And soon we shall have an ECS deployment in all of its glory. I guess one thing I should share while we're here is the Docker file. It's a really simple Docker file. It's not fancy at all. So one thing that I found interesting is I was pulling from Docker Hub, and one time my build failed, and it was a Docker Hub API rate limit error. It said, you have exceeded basically your rate limit. We weren't able to pull node 16 anymore. And I'm like, what are you talking about? And so I did a little Google, and of course Google found and said, yeah, because anybody and their brother who's using code build, it all comes from Amazon, private network internals, probably in the regions that they're in, but we're talking millions of users. I don't know, maybe not millions, but lots and lots of users. The rate limit gets exceeded all the time. And so, yeah, you can have builds fail for that. So that's when there was some other solutions, but I was like, wait a minute, why can't I just pull from Amazon's ECR? And sure enough, Amazon public ECR, AWS, Docker library, node 16. So take a note, if you're pulling from Docker Hub, you're going to need to figure something else out, most likely. or sign in. There was some other solution like you sign in or something like that. Whatever. Yeah, so API server, copy all the files in, npm CI, run build, npx Prisma generate, because this project is using Prisma, which is a really, really awesome ORM. Highly recommend it. I've just started using it recently. It's freaking fantastic. Holy cow. But let's check our logs. Oh, it looks like we're getting close. Sorry, I know you all were really into that Docker file, but we have a code pipeline to look at. Ah, it failed. The deploy failed. Invalid action configuration. Interesting. And this is why, because see this? Our service died, most likely because it was sitting there spinning, and it didn't have a repository to take from. So it just killed itself. So now we go into Elastic Container Registry because at least the build step succeeded, which is great and awesome. It means it built and pushed to our registry. And here it is. We have, voila. So now for the 12th time that we've done this, let's create a service. No change other than the exact same thing we've been doing. But just again, service name, nest, rest, service. Oh, I clicked a button. Dang it. Wrong button. Okay. Task, networking, VPC is fine. Security group, load balance, application, load balancer, create. Oh, nest, rest, dash, LB. Create load balancer, target group, nest, rest, target, health check path, API, create. Now something's going to happen. Something is definitely going to happen. I promise. Well, while we wait for that to figure its life out, I guess we can read a Docker file again. You guys enjoying reading Docker files? Is that why you come to this channel? Because you really enjoy reading Docker files. Well, I don't know about you, but I really enjoy reading Docker files. Some of you astute members of the audience may notice right away that I'm setting in the Docker build file things like session secret keys and encryption keys, which for those of you who aren't aware is a huge no-no. Don't do that. Stop it. Just don't. Don't do it for so many reasons, but the biggest reason is these keys right now are currently stored in my repository in GitHub. So the entire world could just come to my public repo and open this Docker file and see what my encryption key is and my secret session key is. What am I blind? Where is the Docker file? What am I? Oh, there it is. Okay. I'm sorry. I'm blind. But yeah, anyway, here we are, GitHub. Secret information that should not be in GitHub. This should never be, so don't do it. This is a demo. So I set them like this so that I don't have to set them in AWS. But you would absolutely set these in the environment variables. And actually, there's even better ways, but the better way than this is to set them in AWS, where we were setting our task definitions. So when we were creating task definition, create new task, when you come down here and add environment variables, this is where you would set things like encryption keys, session keys, stuff like that. But you'll notice that even Amazon has some other things that you can do. You can add an environment file that you're stored in a secure AWS bucket. There's even things that you can do from an application standpoint in your code. So in code, you could write code that will connect to, let's say, an Amazon key management system or some other key management system. Ideally, not the database that this is connected to. You don't want to store the same keys in the same database as the application. If the application got compromised somehow and you were storing those keys in there, specifically because yes, you can store the keys encrypted, but now you're kind of reaching a level of inception where it's like, well, how many times do you encrypt this? Because I need to decrypt it in order to be able to use the key. So then you ask yourself, well, what key should I use to encrypt my encryption key? And you start down that rabbit hole. And one of the answers to that question is don't. And store your keys in a key management service like Amazon's KMS. There are others out there. I don't have any that I can weigh in on. I actually haven't learned enough to really say much about that topic. All I know is that there's plenty of people out there saying that even having environment variables with your keys is not optimum. Sure, that's the way it is done a lot. I can agree why that might not be optimum. However, adding a key management system adds complexity. And for these demos and for even, making a project or whatever, a small project that you're working on, you don't need to jump through all those hoops. You're just playing around, you're learning. This is totally fine for learning, but I would be a terrible educator and content creator if I didn't at least mention that this is a really, really terrible bad practice that you should never, ever do, except for right now. All right, let's see what the heck's going on in ECS land. Clusters. 1 pending, 0 running. What's going on? Tasks. Pending. Okay, let's look at the NestJS service and logs. What do we get? What do we get? What do we get? Are there no logs yet? No logs. Configuration and tasks. This doesn't look good. Okay, so whenever you see more than one of these in here, it means that it's trying to do it again. Not great, not great, not what we want. Logs. Did the logs give us nothing? CloudWatch. Permission denied. Why would start production.sh be denied in this container? That doesn't make sense. Permission denied. Okay, well, let's take a look at something. This should not be. Actually, let's look at it in here because this is one that I just built not too long ago. Open in terminal. Of course, this is running, so of course it had permission. Why is this running with permission, but the other one isn't? L. Start production root. I mean, it's owned by root. I mean, it has executable. Why would that permission not be available? Permission denied. Well, fudge. Okay, let's retrace our steps. We have code build, ECR, latest image, what? Sometimes I swear I never you know, you can't just have anything just go right, you know, the first time around. And then you end up with things like this. Things that make zero sense. Like here we are working, like literally. This is just npx prisma migrate deploy bin bash. Is there no, what is going on? And yesterday when I was playing around with this, it ended up being the image. I was using Node 18 from Amazon's ECR. And yeah, it didn't like it. It was seg faulting, which is really weird. And it was only doing it in Amazon. It was only doing it in Fargate. And so I rolled it back to 16, and then it just magically started working again. So yeah, fun stuff. ABI server, start production. Like none of this has changed, right? So like I'm running this exact Docker file right now. I've built it locally. I'm running it right now. How is it that there's no permission? Well, come on, Google. Give us a hint. Okay, here's what we're going to do. And there's absolutely zero reason why this should work. We're going to run ch mod plus x. And just to make sure that I'm doing this right, ch mod plus x. What am I doing? Start production. That's what I'm doing wrong. Wait, is that what's wrong? No, start production. Yeah. Okay, and then ch own root boot. Okay. Okay, save. And we'll push this change. I know it's going to yell at me if I... No, it should be fine. Stage changes. Docker. Commit, sync, and pull. Yes, okay. Just now, code pipeline, succeeded, build details. This makes zero sense, guys. Now, why? Oh, fudge. Fudge, 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 fudge. I mean, we now at least know that it's pulled the container in. Understand at all. feel like, I swear, I really do. I feel like these images are changing, because yesterday the problem was this. I was using Node 18, right? And so here you see I'm using Node 16. And, you know, so obviously there's some issues with images, because yesterday Node 18 did not work. It was seg faulting with this. Like no explainable reason I could find. It worked everywhere else except for in Amazon on ECS. Yeah, that was just so totally weird. And so I rolled it back to 16, and then it just started working again. And well, here we are today. I'm doing a video, and of course, using the exact same code, and it doesn't work, and for a totally different reason. And for some wild reason, yeah, can't start. But here we are. This is exact same scenario that I was in, where I'm literally running it locally in a Docker container, right? So it's not even like a my machine thing, right? This is what Docker containers were invented for. It's so that this doesn't happen. And here we are, it's happening. I am running it locally just fine. It works great. Just to prove to myself that I'm not crazy. Bam, there's the local app running on my machine. And here we are in ECS, and it won't start. Same exact container. I've made no changes other than the changes that I just made just now, and push that to chmod plus x chown root start production.sh. Yeah, I don't get it. I don't understand at all. And honestly, if this doesn't work, the very next step is, quite literally, changing the image. I'm just going to change to a different image. In fact, let's look. Can we see? Oh, no, I want actual, not docs. I don't want docs. Gallery. Okay, Node. And it was definitely not, but I mean, Docker library node by Docker verified account. So these are official-ish, whatever verified account means. Okay. So, and then if I wonder, how can we see when these tags were pushed? So if we go to 16, it was updated 1 day ago. Is it this one? Nope, 3 days ago. I think it's Bullseye. This is the default one. It's Bullseye. Yeah. 3 days ago. So what image does this even pull? Let's paste this in. Public ECR AWS Node 16. Docker library Docker. Docker library node. Slim. Quick reference. So node version. This is the de facto image. If you're unsure about what your needs are, you probably want to use this one. It is designed to be used as both a throwaway container, mount your source and start the container of your app, as well as the base to build other images off of. Some of these tags may have names like Bullseye or Buster in them. These are suite of code names for releases of Debian and indicate which release the image is based on. If your image needs to install any additional packages beyond what comes with the image, you'll likely want to specify one of these explicitly to minimize breakage when there are new releases of Debian. This tag is based off of build pack depths. Build pack depths is designed for the average user of Docker who has many images on their system. It is by design as a large number of extremely common Debian packages. This reduces the number of packages the images that derive from it need to install, thus reducing the overall size. I feel like it's this one. It says updated 3 days ago, but I don't know. Not sure if I believe it. Buster. Let's do main. 16. 2 days ago. Just the main branch. Okay. Yesterday. What were they doing yesterday? What did they commit yesterday? Featuring node. Yeah, they did this yesterday. Okay. So, if this fails again, let's see. Push code deploy pipelines. Did it go all the way through this time? No, of course not. Why would it do that? Invalid action configuration. Fine. Okay. So, ooh, what's this? Something happened. All right. It appears to be running now. And I can only believe that it's because we changed this. So by the way, because I have in my task definition to pull the latest tag and it was cycling through task definition 1, always pulled latest. Where was this? Where is it? So it's basically if we create a new revision, we'll see it. So yeah, we look at it, it's just going to say latest. And because the build succeeded, we refresh this, another version, the latest version. So that latest version includes this garbage code, which shouldn't need to be ran because this already was owned by root and it already was an executable. FML. But anyway, moving back on. Let's go back to the code pipeline and fix this really quick. Edit. Edit this stage. Edit. Okay. Yeah, I don't know why it says it was bad. Source artifact? Build artifact. By build, that's what we wanted. Amazon ECS deploy. Okay, done. And save. Save. Invalid action configuration. Retry. Stage deploy was successfully retried. Pipeline was successfully saved. Failed just now. Invalid action configuration. The AWS ECS Container NestJS 2 API does not exist. The AWS ECS container Nest REST 2 API. Oh. Oh, okay. I think I know what's wrong. In my task definition, I need to say, no. Task definition, this guy, create new revision, Nest REST 2 API. Weird. Okay. Create. So this is going to create a new version of the task. And I will need to restart the service. Close this. We'll go back to clusters, ECS cluster, Nest REST service, edit service, use revision to the latest, right? And hit update. Nest REST does not exist in this task definition. Edit service. Okay, delete service. Even though we just went through this, this is now the fourth time we're going to create a service. And this, of course, is happening because I'm trying to make a video about it. I literally walked straight through this the other day, and it was fine. Okay, create service. Launch type, Fargate, latest, service, task, family, Nest, REST, latest 2, service name, Nest, REST, dash service. Desire replicas, fine, load balancing, application load balancer, create, Nest, REST. Are you guys getting tired of hearing me say Nest, REST yet? Are you getting tired of watching me create services? I am getting tired of creating services. Nest, REST, Fargate, and health check API. Okay. Health check, grace period, blah, 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 create. And you better work, because I'm going to lose it. What? Nest REST target already exists in a stack. Oh, Jesus. Come off it. Okay, let's change all the names because obviously we're deleting stuff and starting stuff too soon because CloudFormation hasn't deprovisioned this crap yet. Oh my God. Service. Launch type. Family. Revision. Nest REST service 2. Load balance. Nest REST LB2. Nest REST target 2. You know, you could tell me this stuff before I go through all the trouble of typing it out all over again, like right now. Could you please, AWS, tell me right now that this name wasn't going to work when I started typing it in or finished typing it in, whatever. Create. This progress takes a few minutes. It will take some time. Everything in AWS takes time. This video is now, we're creeping in at 1.5 hours to do something that really only takes maybe an hour. If that, I think, I mean, really, I'm talking about what I'm doing and I'm trying to explain things. So the time that this actually takes is usually less. Like, I feel like if nothing went wrong, I could totally bust this out in like 30 minutes. Okay, maybe 45 minutes. But of course, then something's going to go wrong. Honestly, I have about a 50% experience with AWS things going right the first time through. especially when you're dealing with this much complexity where you have ECS and RDS and VPCs and clusters and services and desk definitions and load balancers and the container registry. And then you throw in a freaking pipeline that's going to pull from GitHub and build stuff and shove stuff into an ECR and also say, hey, ECS, there's a new image in the ECR. Why don't you deploy that? I mean, that's a lot of stuff. It is a lot of stuff. Come on, refresh. Something's happening. 0, 1. So this is never good when you see red. Why was it red? But I don't see red here. Configuration and tasks. Running. Okay, things are moving. Things are happening. Takes a few minutes. How about some logs? What are we getting there? Anything? Come on, logs. Pipeline was saved. I'm just curious, like, did it really need to be named Nest REST 2 API? Like, why was that particularly important? That seems a little strange to me. Well, because it wasn't named Nest REST 2 API, it didn't like it. But nowhere in here do I have, except for maybe the pipeline? This stage source. No, not source. I mean, I have Nest REST 2 API here. That's the name of the repo. It just seems weird that it needs to be named Nest REST 2 API. Like, where does that come into play? Why is that important? Delete pipeline, release, change view history, notify. Yeah, interesting. How are we doing? Nest REST 2 has been deployed successfully, and we have good logs. These are good logs, friends and folks on the other side of this screen. Okay, drum roll. All right, I'm hitting network. I'm clicking on the DNS names. This is Nest REST-LB2 load balancer. Fingers crossed. Clicking it. Oh, I feel like that's taking way too long. Why is that taking as long as it's taking? Is it because the load balancer isn't ready? That would be acceptable. If the load balancer wasn't ready, oh, then I could forgive this. Oh, something's happening. Things are moving. Color of page has changed. Let's just take a look at the load balancer and see what it's doing. Site cannot be reached. Availability zones. Nest REST 2 LB. Okay, let's just double check logs. Make sure we're not getting. Nope. Okay, we're not. It's not failing. Networking. So let's look at the load balancer. And we see Nest REST target 2. Forward 2, Nest REST target 2. This is the listener. Nest REST target 2 is IP address 172.30.1.1. You know what I bet this is? I bet you it's... Okay, so I didn't think we needed to do this, but maybe we do. So here we are, we're sitting and spinning, and it can't reach this. it seemed to me like the load balancer being inside of the VPC would have been able to access this. But maybe not. So if we look at networking on our task and come back to the service, tasks, hit this task. So like right now, I know if I hit open for this, it won't work. This is just the straight public IP address. And this is also going to do the same thing and sit and spin. And I know why. And that's because this, well, it's somewhere. We'll start here and we'll work our way toward it. I always forget exactly where it's at. Networking, maybe? Subnet? No, it's this. Let's start here. ENI. Like in the VPC, it's in the networking world. ENI, interface. Right here, security group. Default. So here we are, security group. Edit inbound rules. And we need to add this rule, at least to make the public IP work. But I did not think, close some of this stuff. I did not think that I needed to do this for the load balancer. I know I need to do it for the public IP. But it just seemed reasonable that the load balancer would, I don't know, proxy access to it. Like, it doesn't make sense to me that I need to make a rule here to let this in for the load balancer. Save rules. Okay. Now, bam, there. Bam, there. Okay. All right. That's it. That's an important step. Finding your way to this security group, which seems like, to me, really obscure, right? Like, I guess I just wouldn't have thought I would have had to have gone into a security group to edit inbound rules. To me, this is like a networking thing. Like, why am I in a security group adding inbound rules? Like, how does this, like, I'm used to doing this on a firewall. Like, why am I not in a firewall page right now? I'm in EC2 security groups. I mean, is this their way of saying, hey, this is a firewall? Like, we're going to, block access, control access of, the inbound traffic here? Yeah, I don't know. So, yeah, crazy stuff. So, yeah, public IP address works. So, really, load balancer's potato at that point, I guess. I thought the load balancer was supposed to help us get access to our application a little sooner. A little easier, a little faster. Let's hit our API, bam, auth login. And if we go back to our logs, we should see this. I mean, I already know what it is, so it's probably too late. It's probably already buried. So it's just, well, I got to look it up. My secret password, Nest2Rest admin. Okay. So yeah, if we go to do something like this, hit try it out, hit execute. Of course, it says 403 forbidden resource because we're not logged in. I believe all of these require some level of logging in some roles. Of course, the initial role that's created here for us is a super admin. Yeah, 403 forbidden request. So let's log in. Try it out. We type in nestrest2 at admin.com. My secret password. Execute. And then we should see, bam, we've got some sturf and sturf. And now we should be able to run other stuff because we're super admin. Hit execute, bam. It returned a 200 and a response body. So just to show, or I guess let's just, to make this pipeline work, let's add a route to the top of this here. And where we go do that is closing all. Don't save. F1 auth.controller. I'm just going to do a quick little route here. We'll do @get. Sure, we'll just make it right at the root of auth. That'll be fun. Do some live coding on top of all of this trouble that I've been having. I am a glutton for punishment. And we're just going to return. Hello, governor. Simple route, test route. It'll be under auth. It'll be right at the top. Let's see. Use guards. No, we don't need to use a guard. API response. Okay. Stage. Test. Pipeline. Commit. Sync. Okay. And yeah, rolling up. In progress. GitHub. It is pushed to GitHub and it is being pulled from GitHub. GitHub Anonymous. In progress. And now it's done and building. Okay, so while that's building, let's, I don't know, review something. There's a tutorial here that tells you how to do stuff like Amazon EC2, and I'm going to add notes. That's what I want to do. Because this bit me multiple times. So the code build, add rule to role, and that rule is this guy, copy and paste. Okay. And then this also bit us. We needed to do something with our ECS, for lack of a better way to describe it. We needed to go into really the EC2. So this is a concept that gets kind of hidden and obscured away from you. Under the hood, ECS is, I believe, correct me if I'm wrong, using EC2s. But ECS manages them. We don't need to manage them, which even as I say right now, I'm realizing is kind of a lie, because here we are in the EC2 dashboard adding inbound rules. So I don't know, this might have been a video to like a how-to video, but it also might have been a video demonstrating the woes of AWS. Like, it's never straightforward, you know. And I mean, granted, I'm not an expert. I don't have like tons of experience with AWS. I've got plenty of experience spinning up containers, spinning up servers, spinning up virtual machines, all the way from the hardware level to the software level. I mean, I've written the code that we're deploying today. So I work, you know, when I say I'm full stack, I mean full stack and maybe full spectrum. I don't know. Maybe we need to come up with a better word. Like, how do you describe somebody who, you know, literally traverses the entire stack from the hardware all the way up to the browser, right? As far as web apps are concerned, that's really my forte. I do a lot of web application development. I don't do a whole lot of desktop application development, even though that has come up recently. So I used Electron for that. Just a quick demo. Proof of concept. Yeah, but I use Proxmox all the time, and Proxmox does not give me nowhere this much trouble. Now, granted, I'm not doing a code pipeline into Proxmox. I could. I've done automated deployments into a Proxmox virtual machine, and that's running to this day. That's been a very reliable service. And I tell you right now, I do not have this much trouble setting that up. And that's a way more manual process. We're talking in the terminal, in the console, in the command line, however you want to say that. I've said it about 3 ways now. You know, hacking it out. It's not GUI stuff. Proxmox does have a lot of GUI, but outside of spinning up your VM or your container, that's it. The rest of the time is spent in terminal land. And that is so much easier. And actually, you know what? Maybe that's my problem. Here I am trying to do this in the Amazon AWS console, having all this trouble, when really I should be just hacking it out in the terminal. Maybe that would have worked better. I doubt it, because this is still, the terminal is still basically signaling these exact same services. Yeah, here we go. It failed again. This is so stupid. I'm pretty much wrapped up. Like, I'm not gonna figure this out anymore. Yeah, the AWS EC Container NestREST 2 API does not exist, even though I changed the name of it in the task definition. So the only thing that I can conclude is that it's because I was an idiot, and instead of doing the deploy, doing the deploy at the end while I'm building the pipeline, instead I said, well, we'll just skip that for now and come back to it. Well, that has come back to bite me here. That's exactly what's happening. Yeah, I don't see how I could do this any different. So here we are. Edit stage. Amazon ECS, edit. Action provider, ECS. Build artifact. Cluster name, ECS cluster. Service name. Choose the service you have already created. Oh, we did create a new service. Okay. All right, hold on. Done. Done. Save. It's not running. Done. Retry. Okay, I get it. Failed action. What, you're gonna make me do a whole nother deploy? This is so stupid. All right, if this doesn't work, I'm done. I'm hanging it up for the night. Basically, here's the lesson to learn from this. Don't do the code pipeline until you're ready. Like, just don't. But I'm a glutton for punishment, so we're just doing that. Let's revert our change in the README where we had that space. Take it back out. Commit changes. Yeah, like, I feel like I could build this, right? Like, including, sorry, not this. What am I talking about? The code pipeline. So, like, if we just want to talk about code pipelines for a minute, which I normally don't have this much trouble with. Code pipelines are actually one of the more straightforward things in AWS. Now, I say that. My experience is limited. I've only done code pipelines from GitHub, and I've only used code build. And the only deployments that I've done are either no deployment, where literally everything just happens in the build, and including deployment. So, like, say, for example, building and then pushing a build to an S3 bucket, right? You can do all of that inside the code build. You just run those commands, just like we saw in the build spec. So, yeah, we're basically just running commands, terminal commands in the build spec. So maybe there's some commands that I could write. There probably is. That instead of trying to do this deploy step, I could just have some commands down here that would signal to, however it needs to signal to ECS to say, hey, there is a new image in the ECR. You need, and here's what happens actually. When this actually works, it will create a new task definition, revision, right? So we've done that once already manually, where we went in here and we hit create new revision and basically left everything the same and just hit create. I think what will happen when CodeBuild does it is instead of pointing it to the latest, it will actually point it to the commit hash in ECR. Yeah, so here we are. Yeah, so like this number here, the 6-digit or whatever, 7-digit hash, whatever you want to call it, image tag, right? And then it does exactly what we did from that perspective. When we create a new revision, we then have to go into clusters and go into the service and hit edit service and point to the latest version, right? So that's what code deploy is supposed to do. When this actually works, it does all of that for us. It goes in, creates a new task definition revision, and then it comes into the service, updates this to the latest revision, and hits OK, update, whatever it does. And then you will see in the tasks, you'll see this one running and a second one like starting up, provisioning, running. It'll go through the whole phase, which takes some time, right? And once it's done and it determines that that is healthy, it shuts down the old one, deprovisions the old one. So that's in a nutshell how this whole flow works and how ECS works, where you can, you know, deploy another or a later version, do a new version, and, you know, deploy it here. Code pipeline manages all that for you. Ooh, okay, here we go. What's happening? Is it going to work this time? It didn't immediately turn red, so I feel like progress may have been made. The quickest way to see that is, bam. Okay, see that? Yes, it's working. It created a new task definition. And if we go take a look at it, yep, here it is. It is using the latest tag in ECR. If we hit refresh, bam, this guy right here, EEF7C79. And we see that it's using it here. So then come back to clusters, come back to tasks. We'll see it, just like I said. We've got our old task, revision 2, still running. And if we go hit that endpoint, which I must have closed. Oh, no, it's right here. Yeah, so if we hit this endpoint, you know, we can hit refresh and see that it's still working, right? And try it out, hit execute, blam. So the user is not experiencing any downtime to this. Now, we don't see our new route yet. And that's because that version isn't finished deploying. Once we see, now we see revision 3 is running and the last status was activating. And we see these ones here are still running. We hit refresh. Okay, now task 3 is running. So what this is doing is it's letting it run for a little bit, kind of making sure, right? Is it stable? Is it going to stay running? Because sometimes a container might start and then, you know, a couple minutes later it fails. So ECS is watching all of this happen and making decisions about when it's okay to deprovision. And you saw I just hit refresh there. Task 2, revision 2 is gone. So now if I come back to Swagger UI and hit refresh, we should see right there. That's our new endpoint that we created here. In auth controller, that's this code right here, has been live deployed to this ECS cluster. And if we try it out, hit execute, we should see hello, bam. That's it. Oh my God, this took way too long. You guys, I really hope you enjoyed this content. Hope you enjoyed this video. Give me a like, give me a subscribe. Thumbs up, whatever you want to call it. I think I've worked really hard for it. Yeah, it's been a pleasure. And I hope to see you guys in the next video. See ya.